Guys, today I'm going to talk to you about building your own web app timer. I call it ingredients of a good timer. Alright, so the three big parts of building a good timer are accuracy, visibility, and consistency. So to start her off, we'll be talking about accuracy, which I define as, does the timer retain accurate hours of timing, or does it remain accurate after hours of timing, regardless of what your user is going to do with their client application? And this basically means, is the data being persisted server side, or I suppose there's some other way to persist the data client side, but I'm personally going to go with the server side solution. Two things to keep in mind when you do this are, do I know how much time has passed since the timer was started? And do I know how much time we were keeping track of before we started the timer? Now, maybe you're thinking, time kept track of before we started the timer? That's 0, right? Well, if we had just started the timer, yes, but if we were resuming from a paused state, then that might not be the case. So I'm going to jump over to a sample application I have. It's just a Ruby file. So here we're looking at a timer class, and you can see the two things that I was talking about: time, which is the time we've kept track of so far, and latest start, which is the a date time of when we started the timer. And then we use these two to calculate our current time. Whenever you're looking at the timer, whether it's paused, active, you're going to ask for the current time to get the time. And this is the time we've already tracked, plus the time since the latest start. Time since latest start, if we're paused or if we don't have a date, that's going to be 0. But if we have both of those things, then it's going to be our current time minus the latest start date. So I'll just fire up a console and show you guys how it works a little bit. It's a little dull. All right, so here we go. Timer equals timer.new, no parameters. So you can see we initialize the time to 0. There's no latest start yet because we're not started, and the status is stopped. If we go ahead and start the timer, time is still 0 because we haven't kept track of any time yet. There haven't been any pause states, and our status is active. If we try to look at the current time, there you go. You can see we're tracking time. It's pretty visible, right? Just got to ask every single time. Let's say we want to pause our timer. Let's look at our status again. All right, now we've tracked about 23 seconds, now 24, and the latest start date hasn't changed yet. Now if we ask for the time and the current time, they should be the same because the time we've tracked is the same. Since we paused it, that's when we updated time. You can see right here, we update the time tracked to the current time, and we put ourselves in the pause state. Now if we resume timing, just gonna start it again. We can see this time hasn't changed, still hasn't changed, but our current time starts ticking up again. So pretty simple. That's the basics to keeping track of your time accurately on server side. Now, one thing you might notice is that really all we're doing is keeping track of the time. We don't know when they paused it, how long they paused it for, how long their first session was. We're not really interested in this, but it might be something that your users are interested in, or you as a application owner are interested in. I've created a second file here to demo that functionality a little bit. Basically, I just referred to each of those as sessions, and then the sessions is what keeps your actual current time. So you can see your current time is calculated from all the sessions added up. Whenever you pause or stop, that ends a session, and whenever you resume, that starts a new session. Some questions you might want to ask yourself when you're implementing a server-side solution is how long do I expect these timers to be running? And this can help you anticipate overflow errors. Maybe you want to be tracking your time in milliseconds instead of seconds, or minutes or hours if your time's going to run longer. So yeah, that's pretty much server side in a nutshell. Also, just make note that we are keeping track of the status here. If it's active, we don't want to activate it again because that would override our latest start, and we would lose track of all the time that we had been running before this. Similarly, with pause and reset, we just check the status ahead of time because we don't want to induce any weird states with our timer. All right, so now if you remember accuracy, visibility, consistency, we're moving on to visibility. As you can see, not really that visible. Like, yeah, here, if you had this file, you have a timer, great. All you have to do is come over here and initialize it yourself and type in current time. Works fantastic, right? Don't think many users would want to use this. So here's where the client-side application comes in. We want something a little more visible. We want something that the user can see the time ticking up themselves. And a couple of UI things that haven't been added here yet, which you would really want to do, are time formatting, and also just make it a little more obvious what state the timer is in. Clearly, you've been watching this, so you'd assume it's paused, right? But it's not very obvious just looking at the timer right here. If we play, then it becomes a little more obvious that, yeah, that was paused. All right, so we'll show you a little bit of the code behind this. So JavaScript is the client-side language that we're using. We want to keep track of all our buttons so that we know when they've been clicked, and the display right here so we can update the time shown, like 1, 2. And then some of these variables are kept in the event that data was coming from the server that we would want to keep track of. For example, if we refresh the page and the timer had already been running for 50 minutes, then we would want that to be kept track of here, the 3,000 seconds or whatever, to be initialized right here properly. And we also want to keep track of the status, the time, and the refresh stat, just like we did on the server side, because we don't want to keep going back to the server and saying, hey, what's the status of the timer every second or so often, because then that'll call, not only will you overload your server, but really the time that you show your user isn't going to be very accurate if you're waiting for the response to come back from the server. So we initialize the click handlers. When the play button is clicked, we want to start, pause, we want to stop, and stop button. There's a little more around resetting the timer other than just pausing it. So how does start work? We initialize an interval, and on that interval, we calculate the time, just like we did with the server. We take our tracked time plus the differential between our latest start and the current time, and then we display that. If you see, I've set my interval for 250 milliseconds right here. Really, you could probably set it for 1,000 milliseconds, but just know that the interval is only guaranteed to fire after at least that interval is passed, so just something to keep in mind. You'll notice that we're also checking for state here. This is a really important client side because, as you see, we have if the timer, or if the status is active, then we don't want to do anything. If we didn't have this check, we could set up multiple intervals that just wouldn't even be trackable, because we'd have the first interval set and then we'd start a new interval, and this variable would get set to the new one, but the old one we wouldn't have a pointer to the old one anymore, so we wouldn't even be able to stop that. Yep, similarly here, we don't want to clear the interval if we've already cleared it. Yeah, I think that's pretty much what you need to know about client side, and I'll just reiterate that really these buttons should be indicators of which one's active, and if you want, you can also disable the currently active state so that the user doesn't try to play an already played timer, even though we have the check for it on the back end. And also this should have some formatting so that the user can easily tell this is 3 minutes and 5 seconds. So there you go. There's server and client side, what I call accuracy and visibility. So now what do we need to worry about? We need to worry about keeping those two together, and we need to make sure that they're both reflections of one another, and ultimately make sure that the client side reflects what's happening on the server, because that's where our accuracy comes from. Section is called consistency. So a couple of questions when you're thinking about consistency is, I have two different clients that want to look at the same data. How do I make sure that they're reflecting the same thing? You might say, what is this application? What are you showing me? I didn't want to create a whole demo for this use case because it requires communicating with the server, communicating with the client, sending requests to the server, opening up an API. There's just having a database. There's a lot of requirements for it. We actually at MustWin already have an application called Scoreboard that we use to track how much time we spent on different projects. And it also has client transparency and invoicing, a lot of other stuff. But mainly we're going to be looking at timers. So here what you're looking at is a couple projects in this my development environment that I've created. And you can currently see we're timing the web talks, So let's look at a couple. All right, just going to backtrack a little bit. Gave my tidbit about Scoreboard. What you need to think about when you think about consistency is, when am I sending information from the client to the server, and how is that server sending me information back? So the gist of that, the gist of the answer to that question is, you send the server information when you're updating the status of the timer. So here I'm just playing, nothing is being sent. I will not send any information here to the timer, or to the server. In fact, I can look at the timer here. I think this one actually points to the timing project. Let's see, here's my timer, that's the text with it. Yep, so that's this timer right here. If we go ahead and reload the record, we can see that the time that we paused it is 3:18. So let's start it up here. We can see the status is paused. Yep. All right, I'm just going to clear this out. Show you that information. All right, start it up here. All right, so now we've started it, right? We should see a little bit of difference with the record here. We should see the status is active now because we just activated it. The time is still the same because we haven't paused it. Remember our server-side solution. This is just the time that we kept track of before the timer was paused. But if we look at the current time of this, it should reflect what we're seeing here pretty closely. Oops, current timer. Current time. So 234 seconds divided by 60, it's 3 minutes, and well, now it's 4 minutes. There we go, 2:47. So that was 4 minutes and 7 seconds. You can see it's mirroring what we have there, but if you look at the object itself, nothing on it has been updated since we pulled it. We can look at this updated date if we want to. You can see nothing's happening. But as soon as we pause it, we send a request to the server to pause it, and then that is updated here. Status paused, time 268 seconds, which is 4 minutes 28 seconds. And the updated at has been updated. So there you go. If we want, we can go ahead and look at our request to the server, see what all was sent, if I can find it. There we go. We sent the text, the project ID, and the status. Basically, we just told the server, hey, we want to pause this timer, you figure it out. And the server then actually sends us back all the information we need to know about the timer. It sends us the latest start, it sends us the current amount of time tracked, it sends us the project, its status, and then we update this UI to match the information that we got back from the server. So, all right. If you saw, okay. Now the next question, when does the server send us back information? Well, like I just said, after we send it a request, it sends us back a response that matches the current state of the timer. That's all good and dandy, but what if I have two different clients looking at the same information? For example, two different browsers. This would also be the case with a phone and a browser, tablet and a browser, tablet and a phone, etc. If we start the timer in one client, we want those changes to be reflected in the other client. Scoreboard has a solution to this problem in a pretty interesting way. Basically, when our client window gets refocused, then we go and grab the information for all the timers from the server. So you see I have this terminal focused right now, nothing's happened. This is running, so this one should be running too. As soon as we focus it, see it starts again. Another interesting use case that Scoreboard has is you can see we allow our users to use multiple timers, time against multiple projects. But one special thing about our use case is we only want them to be timing on one project at a time. So there's a couple of ways to get around this. We could make it so our users can't start another timer until they pause their current one. Be a bit jarring and kind of annoying to have to go and pause your timer before you start another one. So what we do is when they start another timer, we just pause their existing timers. And I think that's pretty much the general of accuracy, consistency, and visibility. A little out of order there. I'm going to go over a couple different use cases with you guys, but that's pretty much the gist of making your web timer. Some other things you need to consider are what your use cases are. I just went over a couple use cases of Scoreboard with you. Multiple clients, multiple timers on different projects, only being able to have one active at a time. Some other use cases you might be looking at are things like speedruns. They have splits and they don't really have time to click a play button or a pause button. Are you going to want hotkeys to start your timers? How are you going to time different splits and keep track of those and potentially store that data on your back end? Also, another use case for Scoreboard is what impact does my timer have on other users of the application? So for Scoreboard, anyone that's a part of this project can also see the time that I've been working on it. So what happens if I never stop my timer, or I'm done at the company and I don't stop it and it just keeps running forever? How are you going to solve that? How are you going to let your users solve cases like that? Yep, I think that's pretty much it. Thanks for listening, guys. If you have any questions, you can hit us up at we@mustwin.com, or hopefully some other contact information will be added to this video. Thanks.